holding postdoc from Israel, Norway, and Spain. He is professor of fish nutrition and aquaculture, University of Çukurova of Turkey, and also he is the founder of Aquaspin. Okay, his research field is very broad, from fish nutrition to feed quality, lipid, fatty acid and metabolism. I think today many experts mentioned this word. Okay, macronutrients in aquafeed, feed quality and stress resistance. Over past 25 years, he has been working on marine fish and shrimp larva nutrition. He has published more than 100 papers. So this is the second speaker, published so many papers. I would like to invite Professor Tufan Erdogan to present his topic on challenge accepted fish meal free diet in aquaculture, which is similar to Dr. Zhang, I think. Okay, so Professor Tufan, please. Now it's your time.
Oh, thank you very much, Dr. Bile. I'm really happy to share some knowledge that we have in Europe, particularly in Turkey, with respect to replacement of fish meal in the diet for particular species. So actually the title is quite sharp, but I know that it's quite sharp, but I think we had some challenges and we overcome some issues in this respect. So that's why I choose this title to charm some people in the audience in the webinar. So, but we will discuss it later on. So my presentation will have at least 5 small topics, and then we are going to talk in details in these 5 parts. So let me start with the global macro trends, which is very common all around the world, actually, not only in Europe, but in Asia. So globally, we have some global macro trends, which can be population growth and health, exploitation of resources, and growing middle class, and aging problem, and as well as the climate change, which is really hot topic at the moment all around the world. By touching upon each part, let's say global population is growing, which is expecting to reach 10 billion people by 2050. So I will talk about in details in my next slide on this regard. And also the global fisheries are to a large extent fully explored. And this is very problematic for the, let's say, fish meal resources, which we use in aqua feed and also poultry and some other, animal industry. And the another issue, which is called a macro trend recently, is a middle class, which is growing in large emerging markets and allowing more people to eat different and more nutritious and protein-rich foods like fish and, let's say, meat and eggs. So that's another issue which we are going to and challenging in due time. And consumption of high quality proteins for the old people is very important for their health. So it is quite a combined trends with respect to all these 6 trends together with for the animal nutrition and other issues. And also, of course, the climate change is greatest environmental concern and challenges to the world has ever faced recently. So concerns about climate change are, of course, influencing the dietary choices. But let's start with the population growth, which is a very common graph you may see from all the conferences. But we do know that, or all the let's say, aqua world in data, UN, FAO, OECD, present these kind of graphs. And we know that we are going to reach around 9 or 10 billion by 2050. So, of course, it's going to be food insecure people, which will be around 1.3 billion in due time. So that will be really case. Actually, if you ask me personally, we do have enough food in the world, but inequality distribution of food is not equal. and not fair. So that's why I think kind of an activist talking, it is quite different angle, but let's jump into my presentation because we are planning to produce more and more because of this population growth. But this is another challenging part for humankind, actually. So in the last 50 years, global meat consumption has increased around 70%, increased from 70 million to 310 million. So which means that we are going to need 70% more protein for available today. So that's really important things since we produce fish and animals. So we produce protein. So we need these 70% more proteins. So the new edition of State of World Fisheries and Aquaculture has launched in Lisbon just 2.5 weeks ago. And in this context, new FAO concept of blue transformation will align with European Union Sustainable Development Goals. So as aquaculture producer and feed producers, we have to take into consideration of these European Union Sustainable Development Goals. So this sustainable aquaculture expansion and intensification to support global food security targets and satisfy the global demand for nutritious aqua food is going to be very, very important things. So, but we need to see how we can going to increase the production with respect to this, let's say, blue transformation. So with this respect, global aquaculture production, as you can see in here, from 1907 to 2020, there is a big, let's say, increase during this time. And the main species group that contribute to the top 75% of aquaculture production in 2020 include seaweeds, carp, bivalves, tilapias, and shrimps. So the freshwater fish and species account almost 80% of global edible aquaculture volume. So which then we have to see the projection of 2030. So we do know that increased role of aquaculture for sure. So on the basis of assumption used and launched by FAO in Lisbon just 3 weeks ago, total fisheries and aquaculture production is expected to expand further and reach around 200 million tons in 2030. And the contribution of aquaculture right now is about 41%, and it's expected to reach around 56%. So we need definitely more feed and ingredients for the future dimension of the growth. So this is another graph that explains which kind of species that we mainly produce. As I explained to you before, particularly aquatic algae, and afterwards it comes with the fin fish and cultured in freshwater and crustaceans and so on. I will not touch upon this detail. You may find in FAO webpage of these graphs. And this is also another one which is very important because of the fact that even though we have we do not have enough fish meal at the moment, we also produce some fish meal from our byproducts, which I'm going to touch in my later slides. So I will just skip this one as well. But this is a big scenario that if in 2022 we reach around 122 million tons and we are expecting to reach 200 million tons in 2030, so then we have to, in a way, consider how we are going to do it, because in our hand we have 5 million tons fish meal oil from the fisheries and 1 million tons fish oil from the again the harvest from the oceans. add, of course, 2 or 3 millions from the byproducts and so on. But what we do, the growth of contribution aquaculture will follow like this. We catch fish from the nature, produce a diet, and then produce fish. But it's not going to be sustainable if we are going to in this way. So that's why we need to have a look which kind of things as a nutritionist or as a scientist or as an industry produce some additives or produce some alternative raw materials for aquaculture, all right? So far, concerned research efforts have contributed towards the reduction of fish meal and oil. For sure, we did really good job. But in aquaculture, whether you produce shrimp or fish, there is no single feed, all species. As you can see on the left side, the carp, shrimp, tilapia has a different combination, quantity requirements change within a species. So also the raw materials, that are used in the formula has changed according to species. Like here, you can see that the difference between 2015 to 2025. This is an excellent article written by Hu et al. In 2090. And as you can see here that the feed carp is just only contains the formula of in their feed is only 1% fish meal. And in marine shrimps, it's around 12 or 10% right now. So on the right side or left side, I don't know, I mixed it, but on my right side, raw materials in formula vary with species. So if we consider sustainable growth in aquaculture and feed, we cannot consider as one solution to all species. So it's quite changed, and it must be how to adapt on species specific basis. So this is one concern that I will again push myself to present something. And of course, aquaculture sustainability is going to have some challenges. It can be a biological, it can be an environmental, it can be an occupation of cost areas, and it can be a consumer's perspective in terms of food safety, food quality, and ethical farming standards. But for sure that optimal nutrition is the key to several of these challenges: biological, environmental, consumer, and occupation of coastal areas. All right. So therefore, agriculture, including aquaculture in 21st century, faces multiple challenges, which we know. It has to produce more food and fiber to feed a growing population with a smaller rural labor forces. And secondly, the industry contribute to overall development in many agriculture deepened developing countries. So then we have to consider these issues particularly and definitely in these kind of countries. And we have to adopt more efficient and sustainable production methods and adapt to climate change, for sure. But then we have another challenge. Are we going to feed the world or are we going to feed the fish? So that is very, very important, aligned with the climate change and so on. So far, according to RoboBank infographic, as seen here, regarding with how to feed the world 2050, actually it is published in 2016 or something, but we achieved something in terms of, let's say, overfishing and other sustainability issues in the diets, and also other things which we really contribute. For instance, we really contribute aquaculture in terms of protein production globally. However, we know that we have not done enough and that we must do more, better and faster for the future. Okay, so let's have a look, feed production by species. So we are only contributing for the food industry in the world around 4.2%, which is account 51.4 million tons. So the poultry and pig and cattle production is really, really high. And globally, we produce 1,235 million metric tons global the global feed production, and the global feed production increase every year around 2.3% according to Alltech Global Feed Survey. So let's keep in mind this one. So how we are going to contribute our ingredient evaluation, how we are going to take into account raw material quality. So basically, we have 6 or more, but this is a general, raw material quality issues. The one is sustainability for the future growth and for the sustainability of the production. And another one is a composition analysis of the ingredients, whether it is going to be a fish meal or rendered animals or insect or whatever. So palatability and feed intake, digestibility, functionality during the process of extrusion technology and the expansion and all absorption and so on. And of course, at the end, growth, gain, FCR, fecal production and production, product quality and so on. For it is 100% all probably we agree that fish meal and oil meet all these criteria, right? Excellent protein and oil sources, but it is certainly a finite or endangered sources. So then let's see what the fish meal history uses. In between 1950 to 1990, it starts with the pig, cattle, and poultry. And in 1990, it starts with an aquaculture. So aquaculture was the, let's say, the dominant consumer of fish meal. But then, right now in 2020, according to IFO, International Fish Meal and Fish Oil Organization, we are much more used fish meal than other industry in terms of pigs and poultry. So as you can see in this graph that we almost 80% fish meal is consumed by the aqua feed industry. So, but another important and interesting thing is that the Ron Hardy, who is the writer of and the editor of the Fish Nutrition book, he was mentioning in 2010 that according to Ron, he postulated that fish meal will not longer be the primary sources in aqua feeds. So what he says is that it will be a special ingredient added to enhance palatability, like an additive, not for protein sources or oil sources, something like that. So it will be an additive in the feeds of aquaculture industry. Is that true? I think it's true because of the fact that between 1975 up to, let's say, 2000, aqua feed version 1 was around like using a fish meal and oil based. In aqua feed version 2 between 2000 and 2015 was related with the law, being mostly replacing fish meal and oil with plant-based oils. And 2015 to up to now, it's changed a lot because we started to use some marine ingredients, byproducts, and some other really important strategic ingredients and functional ingredients. What we have done, concerned research efforts have contributed towards the reduction of fish meal and fish oil in between 2002 and 2010. And right now we really achieved some way. For instance, this is another example which I told you that Hua et al. 2019. And as you can see here that in rainbow trout, there is almost no fish meal. This is an experimental, let's say, result. And in shrimp, it's around 4%. And European sea bass, which is a very carnivore species in Turkey and Europe actually. So it contains only around 15% fish meal, and probably we are going to have less. In terms of other species, with the projection of tacon and methane in 2008, what they assume that in 2020, right now, the consumption of fish meal or the contribution of fish meal is going to very low. So in catfish, it will be 0. In carp, in tilapia, it will be around 1 or 2%. As you probably know from your perspective that we achieved these numbers. But when we consider, let's say, a more carnivore species like salmon, trout, and marine species, we really achieve to replace fish meal, for instance, nutritional value, customer acceptance, availability, price or cost, and so on. So, but I will give an that on in salmon industry. So the salmon industry grows very fast in Europe and all around the world, in Chile and Peru, even in China, I know that. So when the production and total feed use increase, the usage of fish meal and fish oil decrease a lot. So then we have another challenge. We are going to have a less EPA and DHA in the filling, so which creates a problem for the consumer's perspective. But this is not our issue, but we have to consider this one as well. 1 month ago, there was a webinar, and I took this slide from there. So Margaret from the Norwegian Technical University, she emphasized that the aquaculture, salmon aquaculture industry in Norway, which is a very dominant industry right now in Europe in terms of marine production. And he says that they, in Norway, they use almost 12% fish meal in their diet, and 71% of salmon feed is almost plant-based, or other ingredients is going to come next 10 years. So, but the problem is with the plant-based production is intensified crop production, pressure on land and water resources, and of course food competition, which I explained and told before. So by 2030, all fish feed should come from sustainable resources. So then how we are going to be to make this sustainability? So Taken et al. In 2021 has a let's say estimation with respect to production of aqua feed and also fish production. So they think that if the increase will go with this way, let's say a 7.7%, then we are going to need almost, it was, as you remember, 52 million tons. So it will be a 70 million tons. So we need definitely a sustainable resources and of course cheap resources. Oh my God, what happened? I think I have, let me send, hold on a minute. Can you hear me?
Yes, bro. Please
okay,
go ahead.
Just, I don't know why, but the PowerPoint doesn't want me to follow because I speak too much, I think. Okay, I will go fast. I'm sorry for this technical issue. Okay, I was here, right? Okay, so then when I took some figures from the reports of private companies, so they think that the plant-based diets, it's around 0.5 or 0.8 dollar cents. And if we produce diet with fish and fish byproducts, it is around 1.3 to 1.5. So in Europe, the production cost of diet is around $1. If you produce it less than $1, then you are going to do good business. But when we consider the microorganisms or other alternatives, then the price goes up because of the production cost of these ingredients. So then, let's see, is fish meal free concept, which was with a sharp title, but is it realistic or not? Actually, I took this presentation slide from the presentation from Glengos, this one, and he just put excellent photos. So that's why I just want to share with you. So these are the alternatives that we have in our hand right now, even low or high scale production and so on. But when I read different articles, current literature, where they try to find functional raw materials, these are an excellent articles that I really recommend who is working on alternative ingredients, because these researchers hasn't emphasized that we are going to do it, but we have to do a lot, which I will talk you later. So skyrocketing raw material price, scarcity of quality raw materials, and dwindling global supply chain have put a serious pressure on feed formulators and on nutritionists and on industry. So worldwide, to provide quality feed at sustainable price will be the key issue. So what are looking for functional novel ingredients in aquaculture? First is first, very hot topic, develop sustainable ingredients with a low carbon footprint. So that's very important, underlined, red marked issue in here and all around the world, I think. And maximize the use of existing ingredients. So there are, of course, different alternatives, but I think in Biomin and Biomar, things that these four sources, plant-based sources, terrestrial marine sources, and rendered byproducts and unconventional sources will be feature of fish meal substitutes. Okay, let's go with small details in each one. I will introduce you some SWOT analysis in these beautiful ingredients. So as Dr. Raji explained, that plant-based protein sources are very important, soybean, rapeseed, sunflower, and so on. But we have to consider the let's say a replacement, ratio in the diet, because of the fact that immune response is highly influenced by the nutritional background, and use of plant-based diets is often accomplished by intestinal inflammation and inflammatory cells, as explained in previous researches, that it is very important. So that's why we use these kind of organic acids or other alternative additives to cooperate together with these plant-based product or other ingredients which will be used in the future. In addition to that, their wide range of uses for human feeding, cattle feeding, and biofuel production, which will be a let's say, which have been a compete our industry. Actually, we compete with our industry because the price is going up and up. So this can create a big problem in the industry, because of these competitors among industry will have problematic concerns in this respect. On the other hand, when we think nutritional quality of alternative ingredients, they are not equal to that of fish meal and oil. So common drawback is low protein content, imbalanced amino acids, which is explained by Dr. Rajiv, that poorly available phosphorus, and lacking, let's say, in terms of fish oil sources, long chain fatty acids, and so on. So depending on development stage also is very important, and sudden change in physiological stage can affect the fish. So that's why very important concerns should be taken into account when we are thinking the plant-based proteins, which we know, because we have been replacing them for the last 20 or 25 years. Okay, so one of the issue is anti-nutritional factors. So there are many anti-nutritional factors, and also plant-based proteins has some mycotoxins, which is very important. Since 2015 to 2022, this is very delicate issue in Europe. So when we have a look, the ingredients produced in Asia and Europe, there are many mycotoxins in their, let's say, composition. And Rue Conchao from Biomin, he explained that in the finished diets that we use in the grow-out period, almost 25% of finished diet has more than one mycotoxins in it. So this can be another problem for inflammatory perspective and health perspective of fish. So let's have a look of the plant-based protein sources SWOT analysis. So production method is settled and established, and most are byproducts of human foods are working very well. The weakness part is processing methods and genetic technologies. Sorry, the opportunities is going to processing methods, which we use the heat and pressures in order to increase these inhibitors in the plant-based protein sources, and genetic technologies, which creates a great opportunity. In Canada and UK, for instance, they produce a plant which contains LC-PUFA, long chain fatty acids, EPA and DHA. So it contains almost 20-25% EPA and DHA on itself, on the leaves of the plant. So that will be a genetic technology. However, we have some weaknesses. We need some long, let's say, LCA wise, because from the process till the end, we have to use these the LCA calculations and nutritional characteristics, like in balancing digestibility, amino acid composition, especially lysine-arginine ratio and lysine-methionine and lysine and leucine ratio in the plant protein sources. And of course, the trade are climate change, water usage and land usage, and competition with the population growth and demands for the human in this respect. When we'll come to terrestrial or marine sources, I just want to focus on single cell proteins, which are very, very hot topic right now in Europe, and there are many European Union calls related with these single cell proteins. And as we know that they increase the digestibility and has a nutritional value compared with the fish meal, and absorption of EPA and DHA is really high. So this is very important opportunities from these three guys in here: bacteria, fungi, and macroalgae. But it could easily be let's say researchers think that in 1 or 2 years time, we see affordable macroalgae with good DHA and EPA levels coming in the market. And we do know that in Europe, the production of these microalgae and bacteria is going to be high. But production volume costs are still major constraints for a wider use in aquafeed industry. So that's why competition with the human and biofuel production is going to another challenging part. And the variable of amino acid composition is also, let's say, critic points that we have to take into account compared to fish meal. So it is variable crude protein levels in their composition, and as I said, quite acceptable essential amino acid, which can be increased by using, let's say, cell walls and other things. But I will not go in deep since I don't have enough time for that. So microbial ingredients by using natural gases has promise in aquafeed, high nutritional content, sustainability terms, they are very important, and there is no any competition with human food, so that's another important component for them, and they can be produced year-round. Not all, it's not, let's say, affected by the climate change or seasonal changes and so on. And one of the alternative guy in here, methane utilized bacteria, encapsulatus, which contains around 70% protein, very good balanced amino acid, and 10% nucleic acid, which is very important for immunology and growth performance of animal. And it contains bioactive compounds like methanobactam and MAP-E or peptinoglucans. So this it can be another candidate which has been working in Norway for the last, let's say, 5 years, but also it contains a very good production efficiency. Not only bioactive compounds, but also production efficiency is very important when we consider these kind of microbial ingredients in aquafeed formula. So, of course, we have some, let's say, strong opportunities. As I told you, digestibility, high nutritional value, some progress in mass production achieved right now. And in China, I think this week or next week, one factory is going to produce this bacteria that I told you in my previous slide. So they plan to produce around 100,000 tons within a year. So this is very promising, actually, and excited news that I heard just 2 weeks ago. And they can be a functional ingredients, not only replacing fish oil, but also a functional ingredients to boost immune parameters of the animals. And heterotrophic single cell proteins are having opportunities for the next generation functional feed, as we think that they are going to be. And also the weakness part is they have EPA and DHA content differs, as I said, and cell wall integrity and wall type can be a weakness part. But as we know that in Netherlands, in Wageningen University, 2 new PhD released that they overcome this cell integrity and wall type problem. So they have some excellent results, which I'm not going to present you, but you can easily find in the literature. But this is already solved. And the trait is the mass production and productivity need improve, and the price per ton has a long way to go. So that's another trait. I will just try to be fast because I think I have run out of my time. But rendered byproducts are very, very unique, and it has been used for the, let's say, 6 years or so in Europe because of the fact that they are of high quality, economically affordable, and environmental sustainable. So the biosecurity, circularity, and or LCA terms, we have to consider these rendered byproducts. Well, actually, as you know, that in Europe or in many other countries in the world, in 2013, the EU lifted the complete ban on PUPs used in animal feeds, but you can use these byproducts in different animals. But the high standards must be employed regarding the production, storage, processing, and distribution and tracing of such products will have been very important, and then it can be used in animal nutrition in the industry right now. So trimmings are fantastic resources, and IFO and University of Stirling publish an overview with this respect in 2016, and the production of raw material from the fish byproduct is going to be 20 million tons. So when we consider now, IFO says that 29% of world fish meal production already comes from the byproducts. It is around almost 4 million tons. So this is very unique, actually, numbers. And what they expect is that in 2025, extra 9 million tons fish meal is going to come in the industry by using the aquafeed industry. So this is very, very unique. And 1.5 million tons oil is going to come within let's say, within 3 or 4 years in the industry. So of course, there are some, let's say, strengths and opportunities, but also weakness and traits in terms of rendered byproducts. Increased digestibility, high nutritional value and price, excellent. And growing production and oil comes from the byproducts are very having an opportunity for the industry. And the weakness is regulation and quality standards, which can be changed during the season and during the harvest time. And standard production is not ready yet. And trait is high variability in the composition and protein quality, like macroalgae or single cell proteins, as I explained to you before. This is very, very hot topic, I think in Europe, but in Asia, as we know that you use insect proteins and oils for a long time, but in Europe, the people are very excited for these unconventional resources. This is a very new results of released by the Robobank. And we know that they are very good candidates which convert low value organic materials to the ingredient, and low environmental impact, high nutritional value, and there are some legislations in Europe to be able to use these products in the industry. As you can see here, that aquaculture industry can use these byproducts as protein, fat, and even live larvae in the under the pertinent conditions according to legislations certified by the EU, but you cannot use whole or dried or frozen ingredients. So you have to produce some protein and fats from these ingredients. And the insect companies that have received the largest investment and stand out for their business for the last, let's say, 5 years. So as you can see here that $430 million has already invested in this industry. And we do know that the Thai Union CP start to produce and start to invest some money on insect production, because it is quite a very important, I think, resources for the animal production, not only for fish, but also for pet food and animal nutrition. By 2030, the Robobank estimates a global market potential is going to be 500,000 tons. You can see here that then the maturity phase is going to finish, and the price of per ton is going to be around 1,500 or 2,500 euros, which is quite equal with the fish meal and oil. So in this respect, 200,000 tons is going to allocate to aquaculture in 2030. Still, it's low and high cost compared to fish meal, and legislation and food safety is very big concerns when you start to produce these ingredients. So, but the projection is 500,000 tons within, let's say, 25 years or so. As I said, in this article, they criticize and talks about what are the main positive and negative things. But in the case of, let's say, insects, it is protein. It contains a high protein, environmental sustainable, consumer expectant. Actually, still there are some concerns about consumers' expectance, but when it comes with the feasibility and cost and environmental sustainability, then the consumers change their altitude on the diet or on the fish produced by the diet containing insect meals and so on. So these are having the weakness and traits for these unconventional sources when we consider the SWOT analysis. So, okay. Fish meal is just an excellent sources of high digestibility, as we know, high palatability, dietary protein with an excellent amino acid composition. But fish meal not be a longer protein sources, but it will be, as Ron Hardy explained, that it will be like a substitute ingredients compared to other ingredients or compared to the last 10 or 20 years production period. So fish meal can be replaced up to 0%, but it will cost. If we are going to consider algae and others, perfect, but it will cost us for now. But within 20 or 10 years time, the cost is going to decrease, and marginally, I think the replacement ratio is going to increase in due course of time. Right now, we can say that no fish, no shrimp needs any fish meal. However, they need in their diet or in their formula essential amino acids, correct protein and energy ratio, less per unit of feed, but better use is going to be considered. So my last slide, towards to fish meal free diets. I think we have done enough, but in terms of product quality and production perspective, we have to do a lot. I think we have done enough, as I said, concerning the above mentioned items. However, a lot remains to be done in the future. Thank you very much.
Thanks so much, Dr. Tufan, for your presentation. I think you cover a lot of knowledge on replacement of fish meal and fish oil with the functional novel ingredient. I think especially for the insect meal, yes, it's very hot. Even in China, hot topic. I think plenty of researchers, they are doing this kind of a project and the research. Yeah, hopefully in future we can produce stable and a big quantity. Okay, let's move to, I think, one question for you, Prof. Tufan. So you have mentioned the insect meal in your presentation. So could you share some application progress of insect protein in aquaculture in Turkey or Middle East? This is a basic information, I think. What's the bottleneck for the insect protein? And what's the solutions to overcome such kinds of bottleneck? Yeah, if I'm not wrong, I think so far we can, all over the world, the total production is around 10,000 tons, right? About that for the insect meal. So please.
Thank you for the question. It's an actually excellent question in terms of when I do this kind of presentation, the first question comes from the audience is going to relate it with insect meals. That's why, as you said, Dr. Bile, that it is a very hot topic. Right now in Turkey, no one uses insect meals because of the price, which is around 2.6 dollars per kilo. It's so in Turkey we use our fish meal, and we harvest some fish meal from the Africa. So we have some factories over there. So that's why the price of fish meal is quite, let's say, less cheaper than insect meal. But it will come. When I talk with the people in Europe, it is definitely be the future of a replacer of fish meal. As far as I know, that in salmon industry, they started to use because they cannot get this fish meal just like us, because we produce our fish meal in Turkey, as I said. So that's why they paid almost the same money for fish meal and insect meal. So they choose this way because of the fact that in Europe they must follow the green deals. So the green deals force you to use this kind of sustainable resources instead of using a fish meal and oil which is going to be harvested from the ocean. So that's one of the things. As Turkey, we are going to be as an associated country, we probably is going to follow the green deals in 5 years' time. So we have some commitments. Our producers have some commitments to European Union in order to export some fish. So we will replace some insect. in the diet. In the Middle East, I'm not sure, maybe in Egypt, probably they started to use, but the production cost is again quite high. I'm not sure in Middle East, the people, let's say in Turkey case, will not use for now insect meals. But there are some applications to decrease the price of production insect meal. Then within 5 or 10 years, we will use them as an ingredient.
Okay, that's great. Okay, any other questions? So I think that's all for the Prof. Tufan. Thanks for sharing and a very knowledgeable presentation. I did learn a lot from your presentation. Hopefully in future we can face-to-face discuss or have a talk about this again. Okay, thanks again.
Thank you.
Okay, bye-bye, thanks.